Start video.
Good morning, Neeraj ji.
Good morning, ji.
Neeraj?
Are you able to hear me, sir?
You are not audible.
Yes, audible. Neeraj audible.
Murthy sir, morning. Praveen sir, morning.
Neeraj?
Yes, morning, Neeraj.
कैसे हैं sir?
ठीक है. How are you?
I'm good sir.
Where are you now located?
वाइजैक चला गया sir.
Okay, yeah. Right. So Vizag is electrically shipped. Good.
गुड मॉर्निंग नीरज.
हाँ, गुड मॉर्निंग. कैसे है?
बस बढ़िया.
We start at exactly 10 o'clock.
मूर्ति जी आवाज क्लियर एकदम
क्लियर सर, एकदम बढ़िया. Even your slides are also visible, very good.
Nice.
Fonts are also very good.
अभी आपने कमेंट दे दिया तो हो गया काम.
Thank you, sir. We want more new faculty to come, internal faculty, so that we understand our own problems and we share our own experiences.
Correct, sir. Correct.
Good morning, dear friends. Am I audible, Neeraj?
Yes.
Yeah, Murthy, you are audible. Good morning, Bharai. Thank you.
Thank you, sir. In fact, it is your initiation
boy.
and your encouragement.
Our boy.
Yes, it's your boy. Your boy is there. So good morning, all participants who are taking time to join this very knowledgeable and very technical in nature this training program during our National Electrical Safety Week. So we have been doing several programs. This is 29th, this is 26, 27, 28. This is 29th. We are doing this program. This is by our internal faculty, Mr. Neeraj Kumar. He is safety and designated electrical safety officer from Vizag. And he has extensive experience, almost 15 years of experience in oil and gas industry. He worked in exploration production in Kayan Energy India. He worked at an offshore gas production platform in British Gas Exploration Corporation, and he joined Mumbai Refinery and worked in projects maintenance department of Mumbai Refinery. Presently, he is working as a safety engineer, electrical safety engineer in Vizag Refinery. He is designated electrical safety officer. Today, he will talk on OISD standard 173 minimum requirements for preventing and containing and suppression of fire in electrical installations. This is very useful subject. Before starting his talk, I request Mr. Jagannath Pagariji to set the tone for this webinar. Thank you, sir. Over to you, sir.
Yeah, thank you, Murthy. Uh, uh, we have with us our in-house faculty Neeraj, who is working in Vizag Refinery and has a wide experience of 15 years in both refineries, Mumbai Refinery as well as Vizag Refinery, in the field of electrical installations. Actually, this training program is he is going to discuss with OISD standard 173. This 173 standard talks about and deals with about this fire prevention and protection of the electrical installations. This is important actually for all of us because these electrical installations in the different locations in the refineries also are slightly not aware area. So this presentation and webinar will give us insight of this electrical installation prevention and protection for the installation which are put in our locations and refinery. So I request Neeraj to take over now and have a fruitful presentation and discussion with all participants. And I also request all participants to be more interactive to get the maximum knowledge from the faculty. Over to Neeraj.
Good morning, everybody.
Good morning, sir.
As we know that we are celebrating 3rd National Electrical Safety Week, and corporate HSC has given me an opportunity to discuss on OISD-STD-173. This standard talk about the minimum requirement for prevention, containment, and suppression of electrical fires in pertaining to refineries and other oil and gas installations. This standard is not applicable to offshore and exploration and production platforms, but certainly applicable to all, nearly all HPCL installations. In this presentation or in this webinar, my effort will be to explain the requirement of OISD 173 in a simple and easy to understand way. If you try to read 173, you may feel sleepy after 5 pages. Here I'll try that the entire content of 173 reach to you in an interesting and easy to learn way. This presentation is divided into 6 parts. First, we will discuss that how we can prevent fire in electrical substations. Then we will discuss how we can prevent and control fire in generating installation, that is your generators and diesel generators. After that, transformer installations, cable installations. Then we will discuss general requirement, the requirement to prevent fire in electrical installation, which are applicable to all installations. And in last, we will discuss a very interesting and important topic, which will be prevention of fire on temporary installations. When you do shutdown in your plants, or you may not doing shutdown, but still need to do some maintenance in a running plant, you will need temporary electrical supplies. And those even though these things are temporary, but they can give a entirely different hazard which are not present in the permanent installations. So those hazards and how to deal with those hazards, how to control them will be discussed in the section 6 of this presentation. So number 1, fire protection for electrical substations. First, we will discuss how the electrical installation, the substation, should be constructed, that precautions to be taken at the time of the construction of substation itself, so that we are effectively able to control fire. And if at all there is a fire, how it can be managed with minimum bad impacts. For that, 4 things to be taken care for the design of fire exits, the door of your substation. They say that you need minimum 2 exits for your substations, and these exits should be located on the opposite end of building. If your substation is a large one, wherein the length of substation may be, I have seen substations which run up to 100 meters, 90 meters, both in Mumbai and Vizag refineries. In that kind of huge substations, the 2 exits will not suffice. You will need 3 or more exits. Now, how we will decide that how many exits are enough? For that, you should see that man trapped in the fire. You assume that there is a fire in the substation and a person is trapped in that. That person, if walk through all your panels and all your VFDs and whatever there, that actual traveling distance to the nearest exit should not be more than 30 meters. This is how you will decide that how many exits should be provided with minimum requirement of 2. So your substation may be some 120 meters. You may end up finding that you will need 4 exits. So the ultimate criteria is man trapped in the fire inside the substation. For him, the traveling distance to the exit should not be more than 30 meters. Now, how should be the door and how those doors should be identified? The door of substation shall be open outward. If there is a, suppose there is a fire inside the substation is filled with smoke and person is trapped inside, and your door is designed to open inside, then person may not able to find where that something to hold and pull inside the door, and he may not able to door at all. Already he is running short of oxygen. So in those conditions, it is said that your substation door should be such that if you push, it should open outside, push and go. And these doors shall also be provided with exit boards. Generally, your fire alarm system will also have exit signboard. If it is not there, it has to be provided separately. So substation door shall also be provided with the exit board, all whatever, how many number you are having, 2 or 4 or whatever. Then at the design stage, you should also take care grade level of cable cellar. Your cable cellar grade level should not be equal or less than the adjacent grade level. You might have seen at many places wherein during rain, especially in Mumbai, I've seen that water flood inside the substation cellar. And why it happen is that your substation cellar grade level is equal or lower to the adjacent grade level. So your cellar should be at higher elevation to the adjacent grade level. Then roof, how the roof should be constructed. The roof of substation shall be provided with adequate waterproofing treatment. This has been found significantly important in the areas which are receiving continuous and heavy rainfall. There have been chances that substation roof is having leak and that water is falling on some HT breaker 11 kV, 33 kV, and in the night the water travel inside the switchgear and there was a big fire. So to avoid that kind of risk, in addition, even though your roof should not leak, but to even take a secondary protection, the waterproofing treatment has to be provided for the roof of substation. If your substation is having a indoor transformer, mostly transformers are placed outside the substation, but if in case substation is inside the transformer is inside the substation, then it has to be dry type. Even though it is not a mandatory requirement, you can still keep oil-filled transformer inside substation, but then firefighting requirement and oil containment requirement will become very difficult to manage, especially for medium or big size transformers. A very small transformer of say 500 liter, you may be able to meet the requirement of firefighting and oil containment. But in general, it is always better to have a dry type transformer if it is to be installed inside the substation. Space heaters. Vizag refinery or some other installations long time back has seen an issue that water start condensing inside the panels. Why it happen? The weather is cold, humidity is very high, and the panel is not in running condition, it is off condition, and space heater is not there. So what happened? Water condense inside the substation and the panel. And when you switch on that panel, your dielectric strength is gone, and there could be a chance of explosion or fire. To prevent that, you must ensure that all switch gears are provided with space heaters, and those space heaters should be in working condition, especially when your switch gear is in off condition. Some substations are found to be in locations which are at higher temperature than your ambient temperature, especially in boiler areas, in some generating stations also. For those, you should ensure adequate ventilation so that temperature of substation do not goes substantially higher than your surrounding. How it is important to fire safety, fire hazard? If the ambient temperature inside the substation is higher than surrounding, then many of the specifications of the panels and other equipment which say that this is designed for a particular temperature of say 40 may not meet. Your actual temperature may be 45 or 80 or 45 or 50. So you should ensure that your temperature inside substation remain at ambient level or lesser than that. Plus lighting. The requirement for substation is 150 to 200. That much lighting you should ensure inside substation. 200 lux we'll try to maintain. Opening from transformer yard to the substations shall be sealed so that the smoke, when there is a fire in the transformer yard, do not travel to the substation. And this is also important with point of view of propagation of fire through openings. So you should ensure that your transformer and your substations, even though located side by side, are isolated with point of view of fire propagation or smoke entry. That is why sealing all the opening from transformer side. This point will be further discussed in the transformer fire protection section. If you are having a indoor capacitor bank, generally capacitor banks are also installed along with the transformers in the transformer yard. But if at all, somehow you end up by putting your capacitor bank inside the substations, then you should ensure that there is a 1 hour fire barrier. 1 hour fire barrier between the capacitor bank and adjacent electrical equipment that will be your panels. So you cannot put that one here is a panel and at 1 meter you put a capacitor bank. That will not work. As per requirement of this standard, OISD-STD-173, you should provide 1 hour fire barrier so that if there is a fire inside the capacitor bank, it do not travel to your electrical items in the substation. Your substation should also be provided with a smoke detection, fire detection system. To rightly install a smoke and fire detection system, you should have ionization and optical type smoke detectors. These smoke detectors should be provided on cross zoning principle, and there should be a time delay device installed in the system. In addition to that, the detail IS 2189 may be referred. Special attention, in my experience, is required to ensure that both ionization and optical type detectors are given and cross zoning principle is followed. Many a time people put fire smoke detectors as and where they like. That should not be the case. A proper calculation should be done on basis of cross zoning principle. If time permits and people require, we can discuss time cross zoning principle in detail, maybe at the end of presentation. Your substations will also have battery banks. To prevent fire in battery banks, there are certain requirements. like your battery bank should be well ventilated. You should have the minimum, I would say minimum 2 ventilation fan. Generally, it is not a requirement of a standard, but my experience tells that if your one ventilation fan is stopped, others should be able to take care. If your battery bank is of bigger size, then accordingly ventilation system has to be designed. The door of battery bank will be provided with lowers at the bottom of the door, so that air can come from these lowers and air can go out from the exhaust fan. So a continuous unidirectional flow of air is available in the battery room. Light switches should be provided outside the battery room. Why? Because there will be hydrogen generation during charging, and this hydrogen may be a source of fuel for the ignition. Light switches are known to generate spark at every switching. So instead of keep putting flame-proof light switches, it is better to put light switches outside the battery room. The light fittings inside the battery room shall be corrosion resistance and gas tight. We generally use flame-proof light fittings. Now, the fifth and most important, routine checking of your battery cells. If your battery cell electrolyte level is not at the right level, or its internal resistance is increasing, then it poses a different hazard. So you should routinely check cell voltage, specific gravity, and electrolyte level in your batteries. This should be done at the consistent, regular basis. Terminal of batteries shall be provided with the petroleum jelly. This is to primarily avoid corrosion and opening of terminals because of the corrosion. Even though this standard do not require checking of internal resistance, but our experience tells that checking internal resistance of battery cells give you further insight which is not available with checking of cell voltage. So that may also be thought of. Now, how should be the firefighting equipment in a substation? There are three things: DCP extinguisher, CO2 extinguisher, and sand bucket. All three are required in a substation if there is a transformer. DCP extinguisher, 10 kg capacity at every 15 traveling meters. CO2, 4.5 kg capacity every 10 traveling meters. Sand buckets are required, one in each transformer yard, transformer way. So DCP and CO2 inside the substation at 15 and 10 meters, and sand bucket in the transformer way. Then what to do about cable cellar? Cable cellar shall be provided with the smoke detection system as provided in the substation. In addition to that, hydrant, which are not used in the substation, may be provided in the cable cellar to fight the major emergency if they arise in the cable cellar. The word used in the standard is may, means it is not made compulsory. Seeing the congestion in the cable cellar, seeing the size of cable cellar, it may be decided that whether hydrants will be provided or not provided. Cable trenches inside substations shall be filled with non-flammable material or covered with incombustible slabs. Generally, we provide slabs. So your cable trench inside the substation shall be covered or filled with sand. This completes requirement for fire protection of electrical substations. Now we will discuss fire protection for generating installations. This section will have two parts: fire protection for gas turbine generators or your main generators, and fire protection for emergency diesel generator. Let us see what are the requirement for your main generator. That will be generally gas turbine, may also have naphtha or diesel as fuel. So in case there's a fire in generator, the first thing you should be able to do is cut the fuel supply to the generator. How it can be achieved? For that, you should have one RSOB or MOV on the fuel supply line in an open area, not near to the generator. Provide a remote control solenoid operated valve or a motor control valve in an open area on the fuel supply line of generator. This is a mandatory requirement. In addition to this remote control valve, one manual control valve is also required. In case your remote control valve do not work, then how do you cut the fuel? A manual control valve shall also be provided, and that will be provided near to the gas turbine. Sometime you will need to cut both your ROSOB and your manual control valve. Both need to be closed in case of leak or so. Now, if you are receiving fuel from a fuel oil tank, and the capacity of fuel oil tank is more than 45 kL, then three things need to be taken care of. You need to provide two separate and distinct earthing connection to the cell of the fuel tank. If your fuel tank is of bigger size, which generally may not be there, but if at all your fuel is coming from a huge tank, then these earthings shall be available every 30 meters across the circumference of the cell of the tank. Roof and cell of the tank shall be made electrically continuous. If it is a fixed roof tank, no issue, already continuity is there. If your fuel oil tank is a floating roof tank, then you are supposed to provide bypass conductors and internal shunts. Shunts which are inside, not outside. Earlier tanks are having external shunts. So roof and cell continuity will be maintained. To avoid generation of static electricity in your fuel oil tank, you should provide discharge and fill and recirculation lines discharge below the liquid level. The lux level requirement for the turbine area for generator area is 150 lux. This is so in case of fire, people should able to locate firefighting equipment and use them effectively, the minimum requirement is 150 lux for the turbine area. Now, how should be the firefighting equipments for a turbine generator? Generally, turbine generator comes with both is fire detection system as well as firefighting system. Firefighting system is many case a CO2 flooding system is given, but this standard requires that fixed fire water spray system, not CO2 flooding. Fixed fire water spray system shall be provided for the gas turbine generators. In that fixed fire water spray system shall be at 2 levels. One for the area below the operating floor. Generally, your turbines, gas turbine will have an operating floor, above which your turbine and generator and all will be installed. Below that will be a below operating area in which your new oil tank will be there and many other things will be there. So one fixed fire water spray system for below operating area and another fixed fire water spray system for firefighting around the bearing housing. Leak of lube oil from bearing housing is not uncommon. And for that, a fire water spray system is required by this standard. Now, why these requirements are given is that people found that if you try to extinguish turbine fires with CO2 or a DCP, then there are likelihood of reignition. And sometimes the quantity of DCP or CO2 may also not be sufficient to cope with the long duration fires. If you're connecting fire water, then you can fight the fire for hours altogether. But your CO2 and DCP has a limit, will definitely have a limited time period. So for that reason, it is felt that primary fire protection system, firefighting system for turbine will be fire water spray. In some cases where you feel that CO2 and DCP is also essential, then in addition to the basic fire water spray, backup system can be of CO2 or DCP, but that will be only considered as a backup system. The primary system will still be fixed fire water spray. Now we talked about कि generator के अंदर क्या करना है. Now what you need to do in the generator room, that housing of the generator. Generators are generally not put in the open air; they are put in a industrial shed. Those industrial shed or those housing of the generator shall be provided with hydrocarbon detection, fire and smoke detection, and manual call points. All three things shall be required: hydrocarbon, fire and smoke, MCP. Sometime if the height of your generator room is quite high, I have seen generator shed of height 18 meter or even up to 20 meters. In those cases, the fire and smoke detection may not, detectors may not able to serve the purpose because concentration of CO smoke generated may not reach to those detectors in a sufficient quantity. So in those cases where height of turbine generator room is quite high, then beam type fire detection system may be installed, which work in the principle of light reflection. Now let us talk about emergency diesel generator. What we need to take care for fire prevention in diesel generator installations, EDG. First is their location. How and where the EDG should be located? EDG should be located in a well-ventilated room. You should not put EDG in an open area. It should be in a well-ventilated room with exhaust fans, like provided in CPP of Mumbai Refinery. Provided with exhaust equipment, means that exhaust fan should be installed in that. Now, how and where should be the day tank? Day tank should not be inside the DG room. The day tank shall be outside the DG room. And this day tank shall also be provided with fencing. Preferably, not compulsory requirement, preferably the day tank will be provided with the corrugated sheet roof. Why? So as to protect it from the rain and sunlight. So your day tank shall be outside the DG room, will have fencing, and if possible will also should have corrugated sheet roof. DG shall also have a auto curtain system. It should not be the case that when power went, one person will go and switch on the DG. DG should be auto curtain system. Exhaust of DG. DG is kept inside the room, then its exhaust will fill the entire room. That will not be the case. The exhaust of the room of the DG conveyed outside the DG room by a exhaust pipe. You take a pipe, take the exhaust outside the room. Now, where to take that outside? Near the gate or opposite of the gate or wind direction, or how? The location of this exhaust shall be chosen so that it help disperse the exhaust away from the DG room. So in that case, direction of the door and direction of the wind shall be considered, and then it should be decided where the exhaust of the DG should go. Batteries of DG. Should be they kept in open, closed, where? The batteries of DG shall be kept in non-corrosive, non-flammable container. It should not be flammable, it should not be corrosive. MS का मेटल का कंटेनर लगा दिया, नहीं तो प्लास्टिक का कंटेनर लगा दिया, नहीं चलेगा. DG battery container shall be non-corrosive, non-flammable material. And batteries shall obviously be kept in the well-ventilated location for the sake of generation of hydrogen during charging. And this complete fire prevention requirement for the generating installations. Now we'll discuss what we need to do, what we need not to do for transformer installations. Transformer installations, the firefighting arrangement, fire protection arrangement will be based on the oil capacity of transformer. The oil capacity of the transformer divided into three parts: up to 5,000 liter, up to 20,000 liter, up to 30,000 liter. 5,000, 20,000, 30,000. What we need to do for transformers will depend upon what is the oil capacity of transformer. Now, the entire principle of fire protection for transformer is based on providing either of the three things. What are those three things? Either you provide a separating wall, which will prevent the fire from spreading to the other installation, or you provide separating distance, clear separating distance, so that even though your transformer catches the fire, there is no other equipment or installation near to it, and so other installation will not be affected. So you provide such clear separating distance if you are not able to provide separating wall. If you are not able to provide separating wall, you are also not able to provide separating distance, क्योंकि तुम्हारे पास जगह ही नहीं है इतना ट्रांसफॉर्मर रखने का, जगह मुश्किल से मिला है. Then what you do? You provide fixed fire water spray system or fixed nitrogen injection system, NIFPS बोलते हैं लोग. So as per OISD-173, either of these three can be chosen as per your situation: separating wall, separating distance, or fixed firefighting system. Let us see them in detail. Before we go in the detail, recently CA regulation 2022-23 has been published, which supersede all other regulations and other things. This requires that if your transformer is of 10 MV or more, forget the oil capacity. If it is oil filled and 10 MV and more, then you are compulsory required to provide with automatic firefighting system. So OISD requirement and the CA requirement should be seen side by side. If MVA capacity is more than 10, then along with meeting the requirement of 173 that we just discussed like this, we also have to consider automatic firefighting system. That will be ultimately your high velocity fire water system, high velocity fire water spray system, or nitrogen system. Now, if we are
यार मैंने जो बनाया ना, प्रॉब्लम क्या हो रहा है ना, साला टिपटी है ना.
संजय देवांगन जी थोड़ा म्यूट कर लीजिए.
नहीं है ना हमारा.
संजय म्यूट कर लो.
ठीक है.
री एमिलर बार.
संजय देवांगन म्यूट कर लीजिए.
Okay. So if we are using the first technique, that is, you are maintaining the separating distance. You are providing your transformer in such a way that no other installation or equipment is kept close to it. If there will be fire in transformer, no other equipment will be affected. Then how that should be done? That should be done based on the oil capacity. If your oil capacity is 2,000 to 5,000 liter, you have to maintain 6 meter clear separating distance. 5,000 to 20,000 liters. 8 मीटर क्लियर सेपरेटिंग डिस्टेंस. 20,000 से बड़ा ट्रांसफॉर्मर है आपके पास में, बहुत बड़ा ट्रांसफॉर्मर है. 15 मीटर ऑफ क्लियर सेपरेटिंग डिस्टेंस. If in case you are able to meet your clear separating distance requirement on 3 sides, on one side you are not able to meet, something as came, then you should be provide separating wall. पर ये separating wall में एक दीवार आ गया, एक दरवाजा आ गया, तो क्या करना है? Then in that case, that door which coming in this distance 6 meter, 8 meter, 15 meter, whatever it is as per oil capacity, shall be fireproof door. चलो डोर नहीं आया, एक छोटी सी विंडो आ रही है. Then that window shall be 6 mm thick wide glass framed in steel frame. So there will be a steel frame in which 6 mm thick wide glass shall be put. Then you can put window. Otherwise, go for clear separating distance. Nothing should come in that range. Now you are not providing clear separating distance. You thought, let us provide separating wall. So how that separating wall should be? That separating wall should have 4-hour fire rating. 4 घंटे की रेटिंग. 4 घंटे फायर चलता रहे. Your wall should able to sustain. Now how we can construct that kind of wall? 230 mm thick reinforced concrete wall. 230 mm की reinforced concrete. नहीं तो 355 mm thick brick wall. So if you are using brick wall, the thickness of the wall should be 355 mm or more. If you are using reinforced concrete, thickness will be 230 mm or more. Such wall will considered as 4-hour firefighting rating ka wall. Such wall should be provided around the transformer if you are not able to maintain the clear separating distance. अच्छा, इस वॉल का हाइट कितना रखना है, विड्थ कितना रखना है, कितने दूर तक रखना है? Separating wall shall reach up to the roof level. पर मेरा रूफ तो 8 मीटर ऊपर है जी. 8 मीटर लगाना है क्या? If your roof height is more than 3 meter, then you need not to go up to the roof level. In that case, the height of fire wall will be 600 mm. आधा मीटर से थोड़ा ज्यादा. 600 mm above the top of the transformer. जितना भी ट्रांसफॉर्मर का हाइट है उसके 600 mm ऊपर चले जाओ. उतने हाइट तक आपको फायरवॉल बनाना है, नहीं तो रूफ तक बनाना है. रूफ ऊंचा है तो 600 mm. ठीक है, वो हाइट का देख लिया आप. एक्सटेंड कितना करना है, विड्थ कितना रखना है? विड्थ का भी सेम ही है. जितना भी आपका ट्रांसफॉर्मर का साइज है, जहां भी उसका एंड पॉइंट है, 6 mm बियॉन्ड दैट पॉइंट द विड्थ ऑफ द wall should be 6 mm beyond the end point of the transformer body. तो चारों तरफ 600 mm एक्स्ट्रा रखना है. That is how you will construct the firewall for the transformer. Now ये तो हो गया. चलो आग लगी तो क्या करेंगे, पर क्या हुआ, ट्रांसफॉर्मर आग नहीं लगी है पर उसका ऑयल लीक हो गया. ऑयल लीक हो के जा रहा है. Then what need to be done? To prevent the oil from reaching and polluting the water bearing stratum, transformer shall be provided with certain provision. Certain provision क्या है? Oil containing pit and waste oil chamber. दो चीज लगानी पड़ेंगी, oil containing pit and waste oil chamber. Where that oil containing pit will be provided and where the waste oil chamber will be provided, and how this waste oil pit and oil containing pit and waste oil chamber will be connected and designed, let us see in the detail. पहले बात करते हैं oil containing pit का. Oil containing pit हमको लगाना पड़ेगा if your oil capacity is more than 2000 liters. If your oil capacity is less than 2000 liter, what you need to do? Provide with stones. कौन से stones provide करने हैं जी?
नीरज जी स्लाइड मोड में डालिएगा प्लीज. स्लाइड
मोड में डालने से सर मुझे हेडिंग नहीं दिख रहा है, इसके लिए मैं नहीं डाल पा रहा हूँ स्लाइड मोड में. ऊपर एक
ओके नीरज, ठीक ठीक.
ऊपर कुछ बार आ जा रहा है, so I am not able to see the headings. एक बार मैं फिर से ट्राई कर लेता. So if your oil capacity less than 2000 liters, सिर्फ स्टोन डालने से काम चल जाएगा, पर those stones should be of 40 mm granulation, and those stones will be provided all around the transformers. कितने दूर तक डालने हैं? The width of these stones that you are providing all around the transformer shall be either 800 mm beyond the transformer body or 20% of the height of your transformer. If your transformer is say 2 मीटर का ट्रांसफॉर्मर है हाइट में, तो उसका 20% हो गया 400 mm. तो ट्रांसफॉर्मर बॉडी से 400 mm आसपास तक आपको ये स्टोन्स डालने हैं. स्टोन्स की जो लेयर है उसका डेप्थ क्या रहेगा? 100 mm. So 100 mm depth, 40 mm granulation all around the transformer up to 800 mm. Such should be design of your stones around the transformer. Now my capacity of transformer is not less than 200. Then this stone will not suffice. In addition to providing these stones, you are also supposed to provide oil containing pit. अब oil containing pit कैसा होना चाहिए? The oil containing pit के लिए भी same requirement है. Shall extend all around the transformer up to width 20% of the transformer height. जैसे हमने अभी डिस्कस किया था, 2 मीटर का ट्रांसफॉर्मर है तो 400 mm चारों तरफ ऑयल कंटेनिंग पिट फैला होना चाहिए. Why it is kept so? आपका ट्रांसफॉर्मर से ऑयल निकलेगा तो एग्जैक्टली नीचे तो नहीं गिरेगा, उसमें से इट में गो इवन आउटसाइड. So 20% of the transformer height तक oil containing pit shall be provided or 800 mm. Now what should be the capacity of oil containing pit? इसमें दो केस है. Either in your physical conditions with all your constraint, you are able to provide a oil containing pit which is equal to the capacity of tank of your oil tank. जितना आपके ट्रांसफॉर्मर में ऑयल है उतना कैपेसिटी का if you can make a oil containing pit, nothing like it, best. But in case you are not able to meet this requirement. You are not able to provide a oil containing pit which is equal to the capacity of your transformer. Then what you do? Then comes the case 2. Then you should provide oil containing pit of minimum 1/3 capacity of your transformer oil. Even उससे कम भी चलेगा, 1/3 का तो ट्राई करना है. So if you provided the oil containing pit of capacity less than 1/3 or even less, then what we'll do? वो ऑयल जाएगा कहाँ पे जो निकलेगा? उसके लिए हमारे पास है waste oil tank. We should connect oil containing pit with the waste oil tank. इसमें एक exception है. In case oil capacity exceed 9,000 liter, the provision shall be made to drain the oil away from the oil which may escape or leak. तो उस केस में आपको ये नहीं सोचना कि मेरा ऑयल कंटेनिंग पिट का कैपेसिटी पूरा टैंक के बराबर है, 10,000 लीटर का मेरा ट्रांसफॉर्मर है और 10,000 लीटर का मैंने ऑयल कंटेनिंग पिट बना दिया, अब मैं वेस्ट ऑयल टैंक नहीं बनाऊंगा, नहीं चलेगा. This is applicable up to 9,000 liter only. If oil capacity exceed 9,000 liter, then compulsorily both things will come. Oil containing pit also come and waste oil tank should also come. 9,000 से लीटर से कम है तो you can decide to keep or not to keep the waste oil tank depending upon what is the capacity of your pit. यदि पिट का कैपेसिटी सफिशिएंट है तो वेस्ट ऑयल टैंक मत लगाओ, यदि सफिशिएंट नहीं है तो वेस्ट ऑयल टैंक लगाओ. 9,000 से ऊपर चला गया तो कुछ सोचना नहीं है. You are supposed to provide waste oil tank and oil containing pit both. Now इस oil containing pit तो आपका ट्रांसफार्मर के नीचे रहेगा और वेस्ट ऑयल टैंक आपका ट्रांसफार्मर से काफी दूर हो सकता है. It is also possible that you have used one waste oil tank for many transformers. Refinery में it is very common. 4-5 ट्रांसफार्मर के लिए बीच में एक बड़ा सा वेस्ट ऑयल टैंक बना देते हैं. In that case or in any case, you should connect these waste oil tanks and your oil containing pit with a pipe. Now specifications of pipe are specifically given in the standard. That diameter of these pipes shall be 150 mm or more. उससे कम का diameter नहीं चलेगा. Why it is so? If you provide 5 mm or 10 mm का pipe, that is not able to take the oil. ऐसा pipe लगा के फायदा क्या है? So 150 mm diameter pipe shall be used, and that pipe का material shall also be either steel or earthenware. In case of fire, if you use plastic pipe, then pipe itself melted, and the entire purpose of connecting the pit and tank become useless. So your pipe which connect the oil containing pit and the waste oil tank shall be either steel or earthenware. Diameter 150 mm. वेस्ट ऑयल टैंक का डिजाइन कैसा होगा, कैसा बनाना है? The capacity of waste oil tank shall depend upon the 3 things. How much oil is there in your transformer? How much water may come during rain which may reach to these waste oil tank, and a safety margin. So while calculating the capacity of tank, waste oil tank, you consider the oil from one transformer, or if you are using multiple transformer, then those transformer oil capacity, or the transformer which is biggest in these transformers, the capacity of that transformer, then the water of rain that can come, and keep some safety margin. Ensure that no other drain shall reach to this tank. Our plant will have many drains. Those drains should not route to this tank. This tank should be dedicatedly for transformer oil. This tank shall be provided with a vent so that the pressure do not build inside that tank. And that vent shall be provided with a flame arrestor. ऐसा नहीं है कि वहां पे आपने ignition source बना दिया. So there will be vent on the tank, and that vent will be provided with flame arrestor. The internal surface of tank shall be impermeable. The entire purpose of this exercise of putting waste oil tank and oil containing pit was that your oil should not reach to the water stratum. So obviously your tank should be impermeable material, generally concrete का बनाते. And this complete the firefighting requirement or fire protection requirement for transformer installations. We seen that how the firefighting should be. Separating wall की बात करी. We talk about clear separation distance. We talk about fixed firefighting system. Then we talk about how to prevent oil from reaching to the water stratum, in which we talk about oil containing pit and waste oil tank. This is how your fire prevention and control is done in the transformer. Let us talk about how do we do the fire prevention and fire control in the cable installation. Cable installation में क्या क्या आता है अपने पास में? Cable trays, cable trenches, a cable cellar, cable laid directly buried inside the ground. Generally, that's how we keep the cable. So let us take them one by one and discuss. First, let us take the most crude method, directly buried cable. I have not made the trench. I have dig the soil, buried the cable inside. ठीक है, bury किया तो किया, but you ensure that while you dig the trench for burying those cable, and you left that trench buried for some 1 month. After that, your cable came, and then you put the cable. Then what happened? The paper, plastic, wood, many things accumulated inside that open trench. And over that, you laid the cable. Then the entire purpose of protecting the cable is gone. You should ensure that paper, plastic, rag, wood, whatever it is, flammable material that is accumulated inside that open digged trench is removed before you put the cable in that trench, before you fill that trench. Now in one trench, you are keeping multiple cables, possible. Then you have to take care that HV cables means more than 33 kV, up to 33 kV, and medium voltage cable up to 650 volt should have separation distance of 300 mm. मतलब आपका जो हम जनरली बात करते हैं HT केबल वो अलग रखना है, और जो अपनी नॉर्मल केबल है 3 फेज वाली वो अलग रखना है. उनके बीच में सेपरेशन डिस्टेंस शैल बी 300 mm or more. In between them, there shall be a layer of bricks. Only separation distance is not enough. पहले आप केबल डालो, सेपरेशन डिस्टेंस मेंटेन करो, ब्रिक की लेयर डालो, उसके बाद फिर डिफरेंट वोल्टेज का केबल उसके बाद डालना है. Now let us discuss cable laid in the properly made, जिसमें साइड में आप ब्रिक वॉल बनाते हैं, प्रॉपर ट्रेंचेज, उसमें क्या करना है? First is that your trench shall be closed. You should not keep the trench open. With what they should be closed? With a fire retardant material. Generally हम concrete slab डालते हैं. If your cable trench is inside hazardous area, then you should fill it with the sand. If it is in a safe area, then sand filling requirement is not there. You can simply make a trench, cover it with the cable checkered plate or covered with fire retardant material things, that slabs, and you need not to fill the sand in that trench. Ensure that that area is a non-hazardous safe area. In that case, the requirement of putting brakes or is not there. You can simply put your cables on the cable trays or racks, which will be installed on the wall of these trenches. But minimum distance requirement is still there. Even though you are not filling sand, the minimum distance between the different voltage cables shall be 225 mm. These cables shall be laid on the trays, and the trays shall be mounted on the wall of the trench. This is how the cable trench shall be made in the safe area and hazardous area. Now what we need to do for the cable in the cable cellar?
ये गोपाल मिश्रा से भी बात हुआ था कल, उसने मेल दिया है ना, मैंने फॉरवर्ड किया. उसमें क्या है, जो तुम्हारा एक पॉइंट था ना, सारा लोकेशन ऐड नहीं किया है, वो उसने एक मेल दिया है मुंबई का जैसे दिया है ना, सेम वैसा दे देना सारा लोकेशन का. देख लो एक बार, ठीक है. हाँ,
मूर्ति जी, आप सबको म्यूट कर सकते हैं क्या?
हाँ बोलो. यूनिट वगैरह का है उसमें एक सेकंड. हाँ
मूर्ति जी, आप इधर है क्या?
एक सेकंड लाइन में. हाँ बोलो. हाँ सर, उसमें मैंने देखा मुंबई वाला, उसमें लोग ने लेवल 1 में सीनियर मैनेजर को डाला है, ऊपर में जूनियर को डाला है, उसके थर्ड लेवल में डाला है चीफ मैनेजर को. तो सेम वे में हमारे यहाँ पे जो पहले रहेगा फॉर ऑपरेशन में
बातचीत बंद होने का इंतजार करेंगे, बाद में शुरू करेंगे.
रघु है, है.
I think we can continue. So cable laying in the cable cellar. Cellar में केबल कैसे ले करना है? यदि आपको केबल में सेलर में केबल ले करना है तो you should provide fire detection system, fire alarm system. You should also provide emergency lighting.
हाँ, उसमें देखो मेरे को एक डाउट लग रहा है.
In addition to providing fire alarm system and emergency lighting system, you should also provide fire stops. What is fire stop? कुछ नहीं है, जहाँ पे आपकी केबल्स सब स्टेशन के अंदर आती है, उस जगह पे you need not to keep the opening open. उसको एक fire retardant material से fill कर देना है, so that if there is a fire outside the substation, do not travel inside, and if there is a fire inside the substation in the cable, do not travel outside. That is called fire stop. So your substation shall also be provided with the fire stop at the cellar level. If your cables are going in a control room, which is blast resistance control room, generally refinery will have those kind of blast resistance control rooms, then cable entry shall be through multi cable transits, MCT. MCTs are a very nice medium to take the cable inside the fire blast resistance control rooms. Now, as there's a requirement for providing exit at every 30 traveling meter for substation, same requirement is also for the cellars. At every 30 traveling meter, you should provide exit. Now, if you are laying cables in a overhead trays, what need to be done? ट्रे के नीचे ग्रास और वेजिटेशन कुछ है तो उसको वहां पे ग्रास को वेजिटेशन को होने से रोकना है। यदि आपकी जो ट्रेज है वो हाइड्रोकार्बन पाइप्स के साथ जा रही है, जनरली इट इज कॉमन दैट pipe rack and cable racks go side by side, one below another. Then in that case, to protect your cables from the fire, a GI sheet of adequate size should be provided for the cable trays. If your cable trays are running below the air fin coolers, acid alkali lines, then again you should provide a GI sheet as required for the cable running with hydrocarbon lines. Many times you must have seen that fire retardant coating, which is also called passive fire coating, is done on the cables. Now, where it should be done, where it should not be done. The passive fire coating or fire retardant coating shall be done immediately after end termination. Immediately after end termination of the cable, or at the joints up to length of 1 meter on each side. जहां आपका joint है 1 meter this side, 1 meter that side. At the crossing of the cable or T-crossing of the cables, 1 meter on the each side. If your cables are passing through a high temperature area, some steam line is going and your cable is passing along that steam line, then your cable should be provided with this fire retardant coating. A special attention should be given to vertical length. If you are taking a cable in a multi-story building, then either cable will pass through a vertical trench kind of thing. Then entire length of the cable should be provided with this fire retardant coating, because the fire spread quite rapidly in the vertical length compared to the horizontal lengths. And this complete the fire prevention and control requirement for the cables. We discussed what need to be done for buried cables, cables in the trench, cables in the cellars, cables in the dredge. All requirement we discussed. Now let us see the general requirement to prevent fire in substation, which are not equipment specific, but are quite general in nature. Open cutout in the equipment. यदि आपका ब्रेक पैनल में से ब्रेकर को आपने बाहर निकाल दिया है, now there is a opening left in that panel. Those openings should be closed with a blanking plate. You are not supposed to leave those openings open while you are doing maintenance on your breaker. Cable entries shall be closed. Wall opening on the substation shall be closed. Conduit used for cable entry shall be sealed. These are all normal requirements we all follow. Now, what need to be done for rust and corrosion prevention. Painting should be done at regular interval. Zinc passivated, nickel plated hardware or steel hardware may be used. All of us must be using CRC, WD-40 or similar kind of thing. If those materials are having flammable liquids such as gasoline, benzene, ether, alcohol, then those liquids should not be used on live electrical equipment. You can apply these liquids only on the de-energized electrical equipment. Even you are applying them on a de-energized equipment, you should not immediately switch on those equipment. You should wait for these flammable liquids to vaporize and go away. The minimum time required is 30 minutes. You applied spray on some electrical contact now. Now wait for 30 minutes before you go and start that. If you by chance start it before 30 minutes, the chance is that flammable vapors are still present there and they may ignite because of electrical spark. The general requirement for electrical equipment in hazardous area. If you are using electrical equipment in hazardous area, you should see 7 things before selecting it for that area. What is? The equipment should be suitable to the gas group, suitable to the zone, suitable to the temperature class, suitable to the environment condition of that installation. That installation may be high temperature installation. Your equipment may not fit there. You should also see that electrical equipment that you are choosing as per temperature class, gas group, and zone should also have relevant laboratory test certificate and approval by CCOE or PESO. Both are same thing. So test certificate, PESO approval, suitability for temperature class, suitability for zone, and suitability for the gas group. In addition to them, compliance to BIS, which is anyway there. So while selecting electrical equipment for hazardous area, these 7 things should be seen. Now, how to do the maintenance in those electrical equipment installed in the hazardous area? If you are doing maintenance on those electrical equipment, they must be in the de-energized condition. You are not supposed to open explosion protection equipment, electrical equipment in a hazardous area in the energized condition. They must be de-energized. If you are using a flame or a spark source for doing maintenance, then you should comply with the requirement of the hot work. Even though you are not doing any maintenance on these equipment, still to ensure that their flame-proof property or their explosion protection properties are maintained, you have to ensure that they are maintained in such a way for which their certificate was given. Primarily, it will require tightening of nut bolts, using suitable type glands, or using, if your gland and your equipment's threading are not matching, you are using a extension. That then extension should also be certified as the certification of your equipment. If you follow the requirements, then this will meet the requirement of this standard. In addition to these things, the standard also requires that you should not do any alteration on these equipment. If you are replacing a gland or a nut bolt, it should be of the same type. The glass fitting of the enclosure, generally light fitting, should not be, you should not try to repair that. It should be replaced, the entire fitting should be replaced. Those are the also requirement of this standard. If your electrical substation or if your electrical installation is located near to the hazardous area, then in addition to providing fire and smoke detection, you are also supposed to provide hydrocarbon detection. In case when this hydrocarbon is detected, this system should be connected to your AHU damper. So on detection of hydrocarbon, your AHU damper should automatically close to cut the supply of fresh air from the outside, and along with fresh air, the supply of hydrocarbon will also cut. Earthing, it is also a general requirement that system neutral, CT and PT, non-metallic part, all steel structure, cable, trays, storage tanks, vessels, column, all other electrical equipment and cable armor, all these shall be earth. I'm not discussing in detail because most people know this. Resistance value. For the system, 4 ohm is enough. If you are having a huge substation or generating station, your system earthing resistance would be 1 ohm or less. For tanks, 7 ohm is acceptable. A special requirement of lightning protection requires discussion here because lightning can also be a ignition source. So for lightning protection, OISD-STD 180 to be referred. In addition to the requirement of GDN 180, the requirement given by this standard is that earthing network that will be made for the lightning protection shall not be same which is made for your plant. You will have one earthing network made for your plant and one more earthing network made for your lightning protection. And then you should connect these both networks at 2 different places. It is not okay that you use the network of your existing plant for the lightning protection network also. Static electricity is another source of ignition for hydrocarbon industry. To prevent or control that static electricity, following are the requirements. That all the pipes, valves, storage tanks shall be made electrically continuous by providing bonding or by keeping the resistance at the joints less than 1 ohm. So many times you might have seen that some bonding conductor is provided on the joints in the pipe. Sometimes it is not provided. Both are okay, provided you are able to maintain resistance less than 1 ohm. So it is now your entire structure has come at one particular voltage level. You have made everything continuous. Now, in addition to it, where your pipes are entering from offsite area into the plant area, your tank may be in a different area, then your pipe may be running some 1 kilometer, and then it is coming to process plant. Then all over this length, hydrocarbon is flowing inside that pipe in creating a lot of static electricity. Now, if that static electricity is available inside the hazardous area, somebody touch it, and then there will be spark and it will be ignition source. To prevent all this story, wherever your pipes are entering in the hazardous area, you should earth them. So whatever static electricity that has generated in them in the offsite area will not reach to your hazardous area. A flexible earth provision for tanks and wagons will be provided if a pump is driven by turbine, not by the motor, and it is carrying hydrocarbon, then that pump still need to be earthed. OISD standard 110 is for static electricity, which will discuss these things in detail. In short, I have discussed. Maintenance OISD RP 137 should be followed. Another critical requirement for fighting a fire and for escape of the person is emergency lighting. So emergency lighting shall be provided for the safe shutdown of the plant. You will need emergency lighting for what reason? So that you can safely shut down your plant in case of emergency. And to gain access to your firefighting equipment. So your emergency lighting should be so designed, thinking that at what location I will need light to access the firefighting equipment and to shut down the plant. Accordingly, emergency lights should be placed. In addition to emergency light, critical lights shall, DC critical lights, we should say, DC critical lights shall also be provided. The purpose of DC critical light will be evacuation of people in case of emergency. So you should provide these critical light at which location? You are making it for evacuation. Then along the escape route, assembly point, first aid center, कंट्रोल रूम जहाँ पे लगातार आदमी रहता है, मेन सब स्टेशंस, फायर पंप हाउस. सो ऑल दोज क्रिटिकल लोकेशन जहाँ पे आपको इवैक्यूएशन करना है या जहाँ पे लोगों को असेंबल होना है, उसका जो रूट है, उन दोज लोकेशन यू शुड प्रोवाइड critical DC lighting. In case of small plants, maybe at marketing locations where you may not have an emergency DG, then in place of emergency light, you can use a DC critical lighting for the entire plant because your plant is very small. So you may have only normal lighting and DC critical lighting. You may not have emergency lighting, but the DC lighting should be able to serve the purpose of safe shutdown and access to firefighting equipments. And this brings us to the end of our fifth section of this presentation, where we discuss journal requirement for fire prevention in electrical installation. Now, last and quite important section of the discussion, Fire prevention for temporary installations. What are temporary installation? The installations which are supposed to be in service for less than 6 months will be considered temporary in nature. If you are putting some power supply for more than 6 months, it should be designed as per requirement of like a permanent installation. Now let us discuss temporary installation. Your temporary installation will have 2-3 things. First, a cable which will bring the power, then a main switching station, and then outgoing supply from that main switching station. So your main switching station of temporary supply shall be in a well ventilated housing. You should not keep your temporary supply main switch in an open area. You should also keep adequate operating space around this main panel. हाउसिंग में तो रखा है पर आसपास जाने का जगह ही नहीं है. Adequate operating space shall be provided. The height shall be less than 1.5 meter. रिएक्टर में काम कर रहे हैं, सेकंड फ्लोर पे मेन स्विचिंग पैनल लग दिया. You should keep it at height less than 1.5 meters so that it is easy to access in case of emergency. Now the cable which will bring power to this main switching station shall be armored. टेम्परेरी सप्लाई में 2 केबल यूज होगा. एक तो केबल जो पावर लाएगा मेन स्विचिंग स्टेशन को, और वो बहुत सारी केबल जो मेन स्विचिंग स्टेशन से पावर लेके जाएंगी छोटे छोटे ग्राइंडिंग मशीन, कटिंग मशीन, वेल्डिंग मशीन वगैरह वगैरह को. So the cable which will bring power to the main switching station, incoming cable shall be armored. आर्मर का रिक्वायरमेंट इज नॉट देयर फॉर अदर केबल्स जो आपकी वेल्डिंग और ग्राइंडिंग मशीन का है. इट इज ओनली फॉर द इनकमिंग केबल. दिस केबल शैल बी लेड अंडरग्राउंड कवर्ड विद सैंड एंड ब्रिक. कोई बोल सकता है कि सर हमको सब स्टेशन से यूनिट तक टेम्परेरी सप्लाई का केबल लेकर आना है, उसको अंडरग्राउंड और ब्रिक से कवर कैसे करेंगे? सो द स्टैंडर्ड से that in that case, if you have already not laid a cable which is underground available for temporary purpose, then you can lay it supported on the poles at the height at least 2 meter height. पोल्स पे डाल सकते हैं, जमीन पे लिटा के नहीं रखना है. either underground or at the height. Crossing for the road shall be avoided. But actually in practicality, this will be really difficult to achieve. For that also, this standard gives us the way. Standard tell us that when you construct your plant, you make provisions for temporary power supply. That temporary power supply is available at every 50 meters. So if and those provisions shall be both 3-phase type and single-phase type, flame-proof type. So whenever you need a temporary supply, you put your main switching station taking power from these permanent arrangement made available in the plant for temporary purpose. You need not to lay a cable every time from the substation to your plant and worry about how do I put it inside the soil. So the safest way is your plant should have a permanent arrangement for temporary supplies. There you can connect your main switch. Now your that we talk about incoming cable, now outgoing cables. These cables shall be without taped joints. In refinery, we don't accept any kind of joint. We use cables without joints, even though this standard allow joint with certain provisions, which will be quite difficult to achieve. Tape joint, if unavoidable, shall be employed at the height less than 3 meters. आपको फोर्थ डेक पे काम करना है, बीच में केबल लेके जाना है, फोर्थ डेक तक केबल लटकती जा रही है, उसमें जॉइंट है, इज नॉट एक्सेप्टेबल. Those joint, if at all available in the cable, shall be clamped on either side to avoid strain. कुछ पे कुछ strain नहीं आना चाहिए, so they will be clamped on both sides. So strain will go on the clamp, not on the joint. The cable shall be flexible type, but will have mechanical protection by means of double sheath and fine wire armor. Not the main armor जो हमारा पावर केबल में आता है, fine wire armor. इसको normal terms में बोलते हैं braided cable. So for the cables from the main switch to the temporary supply shall be braided cable. Supply to the main switch will be armored cable. Now, how do we protect our temporary supply and the people working on them? You should have 30 milliampere earth leakage protection device. Those earth leakage protection device should be checked every time before starting the work. आज चेक किया, 7 दिन तक काम करते जा रहे हैं, सर चेक किया था 1 वीक पहले, नहीं चलेगा. Every time you start the work, you should check the ELCB or RCCB, whatever earth leakage protection device is available. If your system is having multiple supplies taking power from main switch, then you should ensure that all phases are loaded suitably so that neutral currents do not exceed 20% of the load current. The balancing of all 3 phases. एक फेज में 100 है तो दूसरे में 110, 105 चलेगा, बाकी 2 में. एक फेज में 100 है, दूसरे में 200 है, तीसरे में 105 है, नहीं चलेगा. The current in neutral should be less than 20% of the load current. The requirement of permanent installation we have already discussed. And this brings me to the end of this discussion. Now I'm all available for questions and answers, if any. Thank you.
नीरज सर.
Yes, sir.
सर अभी फर्स्ट प्रेजेंटेशन का स्टार्टिंग में आप बोला है कि बैटरी एंट्रेंस डोर्स के पास नीचे लोअर्स रहना चाहिए बोला है. इज इट मैंडेटरी?
It is requirement of OISD standard. We have given this requirement in all the projects that we have audited. Mandatory ka, if OISD is mandatory, that is a mandatory.
Okay.
Hello, Neeraj sir.
Yes, please.
Thank you for such a nice presentation. Sir, in the start of presentation, while discussing substations, you mentioned that if we put indoor capacitor banks,
right,
we
sir,
should have a mandatory 1 hour fire barrier between capacitor banks and the electrical equipment. What is that fire barrier, sir? What type of fire barrier we can put?
जैसे हमने बात किया था ना सर कि ट्रांसफार्मर लगाना है तो आपको फायरवॉल लगाना है 4 घंटे रेटिंग का।
हाँ सर।
तो ये कैपेसिटर बैंक के लिए 4 घंटे का रिक्वायरमेंट नहीं है। फायर बैरियर कैन बी अ सेपरेटिंग वॉल which will have 1 hour rating, और some other medium आप कुछ सेपरेटिंग वॉल नहीं बना रहे तो कुछ मेटल का सेपरेशन दे सकते हैं। द अल्टीमेट अंडरस्टैंडिंग इज कि आपके कैपेसिटर बैंक में फायर हुआ तो वो जो आसपास इलेक्ट्रिकल इक्विपमेंट है उनमें प्रोपेगेट नहीं होना चाहिए, even though you are not fighting the fire for 1 hour. So suitable arrangement by means of generally, as per my experience goes, we install capacitor bank outside. We don't install inside. Even if you are installing, you provide a wall.
सर जस्ट एक इसका अगला डाउट था, जो सर मैन्युफैक्चरर्स व्हाट दे डू, जब मतलब छोटे जो कैपेसिटर बैंक दे सप्लाई इनक्लोज्ड कैपेसिटर, मतलब ओपन कैपेसिटर बैंक तो वी पुट आउटसाइड ओनली, लेकिन जो इनक्लोज्ड कैपेसिटर बैंक है उसके बीच में भी क्या कुछ मतलब एयर सेपरेशन नहीं चलता है? वी हैव टू पुट ए वॉल और मेटल वॉल।
आपके कैपेसिटर बैंक ऑयल फील्ड है?
नो सर,
ड्राई टाइप है।
राइट।
This requirement of a firewall or fire separation is only applicable to capacitors which are filled with mineral oil, flammable mineral oil. It is not applicable to dry ones.
Okay, sir. Thank you. Thank you. This clears.
Neeraj ji, this is Naresh from HRRL. Can you able to hear me?
Yes, sir, you are loud and clear.
It was a very good presentation, and thank you for that. And I want to know about in the general requirement you told about tankages. Tanks will have earth connection for lightning protection with 7 ohm resistance. Means 7 ohm is the earth resistance when you connect tankages.
Correct, sir.
Regarding lightning protection, when a lightning happens, the energy which is dissipating through the tank body will be huge. With this
Correct.
7 ohm, how the lightning protection is achieved?
As far as energy dissipation is concerned, sir, I really doubt that it has a direct correlation with the resistance of earth plate. Even you will not have only one earth plate. The earth plate shall be provided at every 30 meter across the circumference, and all those earth plates shall be interconnected. This will put all the earth plates in parallel and bring the resistance drastically down. So actual effective resistance for the lightning will be not only earth plates. Your earth plate will act as a grounding medium. The interconnection between earth plate will also act as a connection with earth. The earth strip that you will run from the earth pit to the tank, that will also act as a grounding medium. So effective earthing of grid, resistance of the grid will be far lesser. This is a requirement for one pit only. Hope it makes sense.
Okay. But recent examples, a few of the cases for tankages having lightning is catching fire. So what other precautions or additional measure is from the fire protection point of view will help in protecting tankages, large tankages and open area tanks from the lightning?
The detail is given in OISD-STD-173. Few of them I will discuss now. For entire thing, GDN-180 may be referred. That the GDN-180 talk about you make the roof and cell electrically continuous by providing bypass conductor. That is one requirement. Second, it says that you provide shunts inside the tank, internal shunt we call them, so that even though some spark is there, that spark remain inside the tank where oxygen is not there. So use of internal shunt, use of bypass conductor, connecting the body of a tank at every 30 meter to a earthquake. Then it also talks that if there is a joint in your earth strip, those joints shall be soldered in addition to nut bolting or welding, whatever you are doing. I have seen that this requirement is hardly met. The standard requires the joint between the earth strips shall be first soldered, and over and above soldering, you have to nut bolt them or belt them or rivet them, whatever you do for mechanical protection. For electrical protection, you should put soldering so that resistance do not come in the form of joints. So if those requirements are met, we strongly believe that any kind of lighting should not create a fire hazard. Bypass conductor, internal shunt, effective earthing.
Neeraj, can I speak something about this lightning protection? I'm Rakesh Agrawal. In fact, there are two technologies for lightning protection internationally. One is the early streamer technology and one is the delay streamer technology. So I want to know whether any standard is there for the delay streamer technology, because what we are following are early streamer technology. In foreign refineries, they all converted to the delay streamer technology based lightning protection. Would you like to say something about it?
राकेश जी, आप बात कर रहे हैं कि फॉरेन रिफाइनरी हैज मूव टू डिले थिंग. Means exactly what they have done. You have any idea?
Yeah. I want to say, for example, we are providing a lightning conductor on a high mast tower. And there is a point.
High mast पे आप अलग से lightning conductor लगा रहे हैं?
Yeah, in marketing, high mast tower, there is a pole, there is a lightning arrestor at the top.
Which arrestor है, conductor कुछ अलग से नहीं है, एक ऊपर ये रहेगा, metal रहेगा बस.
Yeah,
correct.
Conductor भी in many cases conductor is also there, down conductor is also there.
अच्छा जी, ये थोड़ा doubtful है, means it do not align with the standard.
But तो इसमें क्या हो रहा है कि for example X million coulomb of charge is in the say cloud, the same charge gets generated there, and then there is a spark. And what happens? The charging distance could be say 1 kilometer. I may be wrong, 1 kilometer, 1.5 kilometer, but in there is a technology provided by Lightning Master Corporation, in which what they are saying, ki instead of 1 tip, 2 tip, 3 tip, they are providing multiple tungsten points at the top. So what happens? The effect, if there is 1 coulomb at the top in the cloud, there will be total of 1 million coulomb maybe at the conductor at the point high mast tower, but it gets divided among the different 500 tips. So what happens? The arcing distance gets reduced, and arcing distance is reduced to such an extent that actually the cloud will pass and our lightning will not strike at the location. That is called the delay streamer technology. I can share some of the data with you. We may remain in touch, and then because this need to be brought in our location, we should avoid striking, but we are still working on the early streamer technology. Delay streamer technology means the lightning will not happen at our premises.
आपकी बात सुनने में अच्छा लग रहा है जी. There can be two things. Either this lightning master is playing a marketing gimmick or we have not reached to the level where we understand those things. Either can be possible. As of now, the
Arabian, if you see Arabian refineries, they are all on the delay streamer technology.
Maybe, sir, I'm not aware. As far as the standards are concerned, I have gone through.
Yeah, that is what I'm
OISD.
saying. The standard, because you people are the driving factors for the standard. When there is a new technology, when we propose to the OISD, because OISD standards may be very old, 20 years, 30 years, and now so many development has taken place in this area. So I think you can maybe contribute little bit for upgradation of the standard as well.
Sir, OISD 180 was republished in 2020. I was also part of commenting committee. So the 180 not very old. Still, your point is well taken, sir. We will try to learn this new technology.
Okay, because it is worth, because I was in OISD also, and that time also that lightning master this presentation was made, but somehow people were not so what to say, open. When you people are going to foreign countries, or you have exposure to the top of the line refineries, how they are performing, I think this should be explored. And then we may experiment it at 1 or 2 locations where, for example, one of our plants, Kota plant, there is a high incidence of lightning, because earth cover is not there. All stones are there. 6 inch only soil is there, then stones are there.
कुछ कोटा में फायर हुआ सर लाइटनिंग वजह से?
नहीं, लाइटनिंग से फायर नहीं होता है. लाइटनिंग होने से हमारे इलेक्ट्रॉनिक इंस्ट्रूमेंट गेट डैमेज. अर्थ
वो दूसरा चीज है सर. दैट इज ये आपका जो सर्ज प्रोटेक्शन सिस्टम है वो ठीक से डिजाइन नहीं किया है. इट इज नॉट अबाउट लाइटिंग. इफ योर इलेक्ट्रॉनिक डिवाइस आर गेटिंग hamper because of this, we have also seen compressor tripping because of lightning, and our generators tripping because of lightning.
There are some cases of fire at the vent points in case of lightning. Vent point पे fire होता है कई बार.
तो उस पे कुछ अरेस्टर नहीं लगा है क्या वेंट के ऊपर?
नहीं, वेंट के ऊपर तो अरेस्टर नहीं होता है. इट इज एज पर स्टैंडर्ड डिजाइन OISD 144.
अच्छा,
या
ठीक है सर, देखते हैं. लेट अस सी.
या ओके
सर. नीरज सर, आई हैड अ डाउट सर. ये अपने जो कैपेसिटर, ऑयल बेस्ड कैपेसिटर बैंक है सर, विच आर लोकेटेड आउटसाइड, सो इज देयर एनी स्टैट्यूटरी गाइडलाइन कि उसमें एक इमरजेंसी पुश बटन देना चाहिए?
ट्रांसफॉर्मर्स के लिए is definitely there, and if these are oil filled capacitor, I believe it should be there. Specifically written I have not seen, but requirement of oil filled capacitors and oil filled transformers, as far as my knowledge and experience goes, are always same. And for transformers it is there. With that logic it should be there for capacitors also.
सर ट्रांसफार्मर्स में तो है, बट कैपेसिटर बैंक्स में यहाँ पर मतलब इन रिफाइनरी देयर आर फ्यू कैपेसिटर बैंक्स व्हिच आर विदाउट दैट इमरजेंसी बटन. सो इफ यू कुड गिव मी द पर्टिकुलर OISD कोड सर जहाँ ऑयल बेस्ड ट्रांसफार्मर का है, वी कैन कोट इट फॉर कैपेसिटर बे आल्सो.
इसका रिक्वायरमेंट तो आपको 149 में मिलना चाहिए मैडम, जो ये पर्टिकुलर थिंग है यू आर सर्चिंग.
हाँ सर.
ये RP 149 में शुड बी देयर.
जी, आप उसको देख के एक बार मिस कांदारी जी से शेयर कीजिए. थैंक यू.
ये बाद में एक सेपरेटली वी कैन डिस्कस ऑन दिस.
या यू कैन जस्ट शेयर विथ हर.
राइट सर, राइट.
हेलो, गुड आफ्टरनून सर.
यस सर.
सर ये जो लाइटनिंग LA का डिजाइन होता है, स्ट्रिप एंड एवरीथिंग, उसका अगले कोई स्टैंडर्ड है कि किस हिसाब से उसका कैलकुलेशन रहेगा? बिकॉज देयर हैव बीन कमेंट्स कि जो 25/3 का स्ट्रिप ये लोग बिल्डिंग के पैरापेट पर डालते हैं, दैट इज नॉट एडिक्वेट. तो मतलब व्हाट इज द कैलकुलेशन, वो कौन से स्टैंडर्ड में रहेगा सर?
वो तो बहुत सिंपल है सर. इफ यू गो टू OISD RP 149, उसमें टेबल बना के रेडीमेड दिया है, कुछ कैलकुलेशन नहीं करना है. आपका मोटर है तो कितना लगाना है, पैनल है तो कितना लगाना है, लाइटनिंग के लिए कितना लगाना है, बिल्डिंग की यदि आपका डाउन कंडीशन कितना लगाना है, need not to do any calculation. Ready-made table is available in OISD 149.
ओके सर। दूसरा सर एक और है जो हमारा स्विच केयर है 415 वोल्ट्स का, उसमें जनरली कैपेसिटर बैंक पीछे ही रहता है, उसके इनकमर के पीछे ही कैपेसिटर बैंक रहता है। तो आप जो बोल रहे थे उसमें डिस्टेंस रहना चाहिए 1 आवर पायलट रिले का, तो वो एप्लीकेबल मतलब इट इज अ रिकमेंडेशन और मतलब रूल टाइप थिंग?
सर ये ऑयल फील्ड है कि ड्राई है?
ये ऑयल फील्ड वाले कैपेसिटर बैंक, उसमें ऑयल फील्ड ही है।
कैपेसिटी कितना है सर, कितना ऑयल है?
2.5 kVAR के ऐसे 4 बैंक्स रहेंगे, मतलब छोटा ही है सिस्टम, तो छोटा ही है पीएमसीसी। 2.5 kVAR के 4 बैंक है और एक 5 kVAR का उसमें।
Sir, this requirement is coming from STD-173, which is a standard. So ये recommendation या guidelines तो नहीं है, it is a standard.
Okay.
So that way I say it is a requirement.
अच्छा ठीक है सर, मैं एक बार जरा डिस्कस करता हूँ टीम से, बिकॉज सारे डिजाइन ऐसे ही अप्रूव थे और इन मोस्ट ऑफ द प्लेसेस ऐसे ही है, मतलब एसवी स्टेशंस वगैरह में भी।
उसका डिस्टेंस मेंटेन हुआ होगा सर, डिस्टेंस कितना है बीच में?
डिस्टेंस कुछ नहीं, लाइक इट इज द सेम पैनल है, फ्रंट एंड पे आपका इनकमिंग है और
तो
उसमें
मे
मतलब
आपका
आपका
ऑयल कैपेसिटी बहुत कम होगा, मे बी लेस देन 2000 और समथिंग। जरा देख लीजिए ऑयल कैपेसिटी, एग्रीगेट ऑयल कैपेसिटी कितना है, नॉट ओनली ऑफ वन, इट टॉक अबाउट एग्रीगेट ऑयल कैपेसिटी।
ओके ओके, दैट थिंग आई हैव टू चेक सर, स्मॉल कैपेसिटी आई हैव टू चेक दैट।
यदि बहुत कम ऑयल कैपेसिटी है तो इट विल फॉल इनटू लेस देन 2000 के, उसको अलग से डील करना पड़ेगा।
ओके, एंड सेकंड ऑफ ऑल मेरे सबस्टेशन में है वह हमारे पास बड़ा वाला जो अपना एसटी का कैपेसिटर बैंक है, लाइक 100 300 500 केवीआरस के भी हैं, तो उसमें तो आई थिंक ज्यादा ही रहेगा। तो जो 1 आवर डिस्टेंस करके व्हाट मतलब कैसे सिग्निफाई होता है, मतलब लाइक यू हैव टू एक फिजिकल डिस्टेंस है, कैसे रखना है?
नहीं सर, वो भी अंदर है कि बाहर है, कहाँ पे लगा है?
वो सर इनसाइड ही है, हमारे अंदर ही है सारा, वो इनसाइड कैपेसिटर बैंक है वो सब।
जैसे सर हमने बात करी थी कि 4 आवर रेटिंग वॉल, तो आपका 225 mm का कंक्रीट चाहिए। अकॉर्डिंगली somebody who is in the design can tell कि 1 आवर रेटिंग के लिए कितना थिकनेस का वॉल चाहिए।
अच्छा, मतलब सिर्फ फिजिकल एयर डिस्टेंस से कुछ मतलब नहीं होगा, बीच में एक फिजिकल वॉल लगाना पड़ेगा, ऐसा ऐसा?
एग्जैक्टली, दैट इज द मीनिंग।
ओके ओके ठीक है सर, वो सब मैं थोड़ा चेक कर लेता हूँ। थैंक यू सर।
एक बार 173 रेफर कर लीजिए सर, इट विल मेक
जी जी ठीक है सर, ओके सर, थैंक यू।
नीरज सर, दिनेश इज हियर फ्रॉम एचआरएल राजस्थान रिफाइनरी सर। सर एक मेरा क्वेश्चन है बैटरी रूम के लिए, जो ड्यूरिंग चार्जिंग हाइड्रोजन जनरेट होता है, राइट सर? तो कुछ ऐसा स्पेसिफिक है क्या कि मींस लाइक कितना वो जनरेट होता है इन टर्म्स ऑफ परसेंटेज? और
डेफिनेटली होगा सर, दैट कैलकुलेशन आई हैव नॉट डन। कुछ तो होगा कि इतना बैटरी पे इतना होता है, दैट कैलकुलेशन पार्ट आई एम नॉट श्योर सर।
सर ये बैटरी रूम में हाइड्रोजन डिटेक्टर्स नहीं लगाते हैं, राइट? उनकी जगह पे लाइक हीट डिटेक्टर्स लगाते हैं।
करेक्ट सर।
हाँ, बट हाइड्रोजन डिटेक्टर्स क्यों नहीं लगाते हैं? अगर जब हाइड्रोजन जनरेट हो रहा है तो वहाँ पे हाइड्रोजन डिटेक्टर्स तो होने चाहिए।
सर कोई लगाने से मना तो नहीं किया है, दैट एज फार एज आई नोज, पर रिक्वायरमेंट भी नहीं है सर, इट इज नॉट कवर्ड इन द स्टैंडर्ड कि लगाओ ही लगाओ। But if you put it, I don't think that any standard is stopping doing this. Moreover, standard is dealing with this problem by providing ventilation by means of not allowing hydrogen to accumulate instead of detecting and fighting. If you put detector, what you will do? होगा तो फाइट करने के लिए जाओगे। हाइड्रोजन
हीट डिटेक्टर सर मींस मतलब जब तक फायर नहीं हो तब तक वो डिटेक्ट ही नहीं करेगा।
हाँ, तो उसके प्लेस पे द स्टैंडर्ड है टेकन अप एक स्टेप फर्दर कि लेट अस नॉट अलाउ हाइड्रोजन टू एक्यूमुलेट, प्रोवाइड द वेंटिलेशन। तो फिर ये सब क्वेश्चन आता ही नहीं है कि फायर फाइट करना पड़ेगा, डिटेक्ट करना पड़ेगा, दैट वे।
Mr. Dinesh, this latest OISD guidelines, it is going to come as a revision that hydrogen detectors are going to become mandatory. And that is the reason why VRMP also is now, whatever the construction has happened, every battery room is having this hydrogen detector. So that latest guidelines is getting revised. This year it will be published.
Sir, OISD guidelines, sir.
Yes,
Actually,
yes.
sir, हमारे audit में भी that point came in a recent audit. They have proposed to put hydrogen detectors, but
Yes,
as
yes.
of
That is as
now
per
we
the
have
latest
lowers
guidelines.
and
It is under
this.
draft stage only. It is going to
Yes.
become a mandate now.
हमारा
मतलब
कौन सा
सर
कौन सा
OISD
स्टैंडर्ड में आ रहा है?
हाँ कौन सा स्टैंडर्ड है सर?
149 only.
149 में आ रहा
Okay, fine.
है. Great, great.
सर नीरज सर एक और क्वेश्चन है, लाइक बैटरी रूम है ना, तो बैटरी रूम में 2 एग्जिट होना चाहिए या सिंगल एग्जिट होना चाहिए?
सर 2 एग्जिट का रिक्वायरमेंट तो नहीं है. It is not.
एज पर एनबीसी और फैक्ट्री रूल्स आल्सो, लाइक उसमें भी ऐसा नहीं है.
Whatever I've read till now, I've never come across 2 exit requirement.
बट सब स्टेशन पे मिनिमम 2 नंबर ऑफ एग्जिट होना चाहिए.
Minimum 2, correct sir.
सर जनरली मतलब जैसे हमारा जो बैटरी रूम लाइक कंसिडर करता है कि वो हैजार्डस एरिया, मतलब हैजार्डस है ड्यू टू हाइड्रोजन.
Correct.
तो पर्टिकुलर बैटरी रूम में एटलीस्ट 2 एग्जिट डोर तो देना चाहिए.
Sir, really sounds good, but not covered in the standard.
Okay, sir.
Sir, standards are minimum requirement. Nobody will say you can exceed the standard. You can always exceed the standard. If you wish that you need to provide additional exit gate basis your assessment of the size of the battery room, you may go ahead.
Rakesh, the heading of the standard itself is minimum requirement.
Yes, sir. These are the minimum requirements, and designer has to consider other factors, and basis the factor he may provide additional features, additional requirements.
Correct.
नहीं सर, बट लेकिन एनबीसी में ना सर, एनबीसी में ऐसा मेंशन किया हुआ है कि अगर किसी भी बिल्डिंग्स में अगर हैजार्डस मटेरियल स्टोर कर रहे हैं तो दैट पर्टिकुलर रूम शुड बी 2 नंबर ऑफ एग्जिट.
Then definitely you have to provide because it's a code.
Yes, sir.
It's a code. Then you have to provide.
उसमें पर थोड़ा सा हैजार्डस मटेरियल का डेफिनेशन देख लीजिए. Whether running batteries are fitting that definition. Even though जैसा राकेश जी बोले कि
एक्चुअली ना हम लोग
you can always exceed them.
एक्चुअली हम लोग सर स्ट्रगलिंग कर रहे हैं इस राजस्थान रिफाइनरी प्रोजेक्ट में. सब स्टेशन में तो एक्चुअली दे आर प्रोवाइडिंग, बट एसआरआर बिल्डिंग में वो लोग लाइक आर्गुमेंट कर रहे हैं, दे आर डिनाइंग लाइक नहीं सर ऐसा नहीं होता है काइंड ऑफ थिंग.
मेरा ख्याल है कि जो हैजार्डस एरिया का हैजार्डस सब्सटेंस का डेफिनेशन
नहीं सर, वो हैजार्डस एरिया नहीं डिफाइन किया, हैजार्डस मटेरियल ऐसा लिखा है. हैजार्डस मटेरियल लिखा है तो हाइड्रोजन सर, हाइड्रोजन इटसेल्फ इज अ हैजार्डस मटेरियल. वो गैस जनरेट कर रहा है,
वो आप स्टोर नहीं कर रहे हैं ना सर.
नहीं बट जनरेट हो रहा है ना सर.
The word used might be storage, not generation. देख लीजिए सर.
Okay, fine.
Any questions?
Sir, this is Naresh Kumar once again, sir. I stopped for the lightning protection of tanks in the discussion. My final point is actually the measures which you told that is already part of our system in HRRL. Still, recent examples of Exelon Mobil's tank farm catching fire, or some other recent areas, I mean, recent oil and gas industry tanks are catching fire because of lightning. Specifically, they mentioned because of lightning. So with these technologies and things already established, is there anything which is guaranteed that if a lightning stroke happens, still there will not be any fire?
नरेश जी, गारंटी वर्ड तो कहीं पे नहीं लिखा है, बट एज फार एज वी नो कि जहाँ पे RP 545 या उसके इक्विवेलेंट OISD 180 का रिक्वायरमेंट किसी ने मीट किया है, and they are actually maintained that way, I don't think that there is any RCFA or any finding कि फिर भी fire हो गया. If at all कुछ ऐसा RCFA आएगा, people may say ना कि इसलिए हो गया, but let us see that what the RCFA come. कभी ऐसा हुआ है क्या? In my experience, we have not seen, sir. कि 180 फॉलो किया आपने या RP 545 फॉलो किया and उसको मेंटेन भी किया, still there is a fire because of lightning. Maybe lightning master is a market, Miss company is marketing their product. They may say many things, sir.
नहीं सर, एक्चुअली क्या है, ये बहुत पुराना कॉन्सेप्ट है, डिले स्ट्रीमर टेक्नोलॉजी. इफ यू, I have only taken a name because there was a presentation which I attended. I am not I don't want to promote any name. It's a technology, delay streamer technology, where 4 or hundreds of tungsten points are made instead of a single or 2 or 3 or 4 tips on the lightning conductor. So the charge gets divided and the arcing distance gets substantially reduced. So, but our cloud will be at much higher level and our arcing distance will not be achieved. Hence, the lightning strike will not happen. The cloud will pass. Sir, you please take my these things. Arabian refinery, they have done it. So we can take some kind of, starting point, maybe upgrade this technology.
Correct, Agrawal ji. We will take this as a learning point. Let us see what can be done.
If you want, I can.
We'll try to see what is there.
Because what happens, OISD also, they will take inputs from the industry and give to us only. So we have to provide the right input in order to get the correct.
Sir, OISD ने तो क्या किया है ना, RP 454 को कॉपी किया है, 545 को. वो RP में जो था API RP में उसको कॉपी करके इंडियन कंडीशंस और सिस्टम्स के हिसाब से मॉडिफाई करके रखा है.
As far as आप देखिए, जैसे BPCL में आप जाएंगे, टर्मिनल्स में, आई एम टॉकिंग ऑफ टर्मिनल्स एंड LPG plant, BPC was not giving lightning conductor on the top of the high mast tower, but we were giving, and our premises were having the lightning strikes, and BPC premises were not having the strike. So they had taken a decision at some point of time that we are not going to put this lightning conductor at the high mast. So
अच्छा observation है, sir. It could be published in a proper documented way. It will make a lot of sense to the industry. Please, if it's possible, you document this, your observation, and publish a research paper. It will make a great help to the industry.
Because देखिए सर क्या हो रहा है कि lightning होती है, उसके बाद में those millions of coulombs of charge gets discharged to our soil, and whole soil instantaneously the potential gets increases, and that disturbs our electronic systems. That is my observation.
So Rakesh,
we should work in some direction when the charge should not actually discharge in our premise. It should pass.
Correct, sir. It is a point for research can be done.
So both of these Rakesh sir, both of these technologies are present in the industry, but still from the point of maintenance, because whatever lightning will be there in the early streamer, the lightning stroke will be captured by the technology rod which will be there, and delay streamer will reflect the lightning so that lightning
it will not be reflected. It will not be reflected. It will be delay streamer technology, means in early streamer technology, we are providing a safe path. We are providing a safe path for the safe discharge of the charge. But in delay streamer technology, what they are saying, we are creating a condition when the clouds actually do not discharge in our premises. They will simply pass above from our installation. They will not disturb us. That is a theory.
I think Pagaraji, take it as input, maybe during this YSD standard revisions and all, because it can be deliberated.
I know, sir.
Oh, carry on, carry on.
Yes, noted. This 173 for revision. We will take this as an input. Any other questions? Otherwise, we will wind up.
I have one point. Naresh Kumar from HR also. For fire protection or fire catching inside the panel because of the bus bar fault, the fire will have gas duct path so that the energy will be dissipated. Is there any standard for the duct dimension, or the duct will have a certain length, minimum length is required?
Naresh, you come back. What is the thing?
The internal arc faults or the arcing inside the panel on the bus bars will have fire, and the energy which will be there will be dissipated, and that dissipation of energy will be directed through a duct, the gas duct. For HD panel, it is part of the design, panel design. The duct is routed so that the energy which is concentrated at the arc place is dissipated through the duct and will be taken out from the panel.
Understood.
So the dimensions of that duct and the particular length has to be there. So is there any standard for that?
Definitely, it is not covered in OISD. As far as I know, Indian standard may be covered nahi hai. It may be covered in some foreign standard, which I'm not sure, sir. OISD may definitely it is not there.
Okay.
I think there are no more questions. Neeraj ji, thank you for this informative actually session, and actually more interactive also. So many participants have asked questions, and I hope the doubts of those participants have been cleared very well. Still, any questions are there, then can be write to directly to Neeraj or to the corporate HSC also. We will try to answer your questions. Thank you, Neeraj. Thank you, participants also.
Thank you, everybody.
Yeah. Let us.
Should we close, sir?
Yes, sir. Yes.
Thank you, Neeraj ji. Excellent presentation.
Thank you, sir. Thank you, sir.
Yes, thank you.
Thank you, Hiranmay Bharaji.
Thank you, Neeraj.
Murthy, Pagaraji, thank you.
Thank you, Neeraj ji.
Thank you.
Neeraj, you have to come out more and more webinar. You have a lot of experience, knowledge. You have to share it to everyone.
Correct.
Almost at least within a quarter, you should be presenting one. Okay.
His boss is listening.
Sir, Bharaji, you give him that target.
No,
knowledge,
not only
should be useful for the corporation.
Not only in this safety week, actually, other time also it is to be actually we have to utilize Neeraj for the knowledge gaining of the
you can utilize his services for auditing also.
Yes, well, definitely.
Yes.
Okay, somewhere you are going for auditing where electrical equipments are more and
yeah, correct. Actually,
it was good presentation. It was good presentation in view of upcoming projects everywhere. A lot of standards are going to be revised. These inputs will help in designing those things taken care of at the design stage. Some questions are not answered. Actually, electrical subject is like that only. Being non-electrical person, I could understand few of them. At least I could learn something. It was a good presentation. Thank you.
Thank you, sir.
Thank you, Neeraj.
Thank you, Neeraj. Capability building.